urgent need for us to win there that we started to put more and more resources on this.
So what we would do is our customer would have some general feedback for us. We take that general feedback and use our standard lab tests to help us work better in the lab. We then introduce it to our customer. They would test it in the field, and they would give us feedback whether it was better or not.
Well, so the old way it used to work, in all reality, was quite frustrating. There, and some of the people use phrases like throwing darts, and when you throw darts, first chance of success is
So one thing we realized as we're trying to solve some of these very difficult problems that we've had for decades was that we never had enough time to get to your top. One of the main principles that we follow is going to So whether that was going to the West Texas and speaking with the drilling engineer and operator who was running our bits, or going to the work site where the cutters were being made and being tested.
To me, the West Texas High Velocity SPDCA is all about rapid learning, developing trade-off orders, and then really getting together to get to the end user of the product, understand the problems that they're facing, and then you can be able to develop solutions for that product and those problems. Working on an HVDT is different than how we're historically. Pretty much everything.
Since we have moved to this new problem-solving method using HVDTs instead of our smaller isolated, we do feel a lot more supported in our product design.
So I really do geek out about the new way of working. I really like it. Again, because I like that I can see research make it into products in a way that makes a difference.
I think the customers love this all. I've heard feedback from customers saying that they want to do this in more areas.
In face-to-face conversations, as well as feedback from customer engineers in response to what we've been able to accomplish has been overwhelmingly positive. Comments that we've never really heard from customers. This is the best work we've seen. This is where you stop talking and sell us a bunch of product.
I'm going to West Texas and show one of the product goals. Oh yeah, that's it. Get some credit. What we tried to do was instead of batching the way we did work with 20 people working on the same problem one part-time, we took 5 of those people and asked them to do full-time to one problem. We saw huge velocity out of that. Instead of taking 1,400 days it used to take us, we got that down to about 270 days to launch a product that was commercially adopted. The other thing that we were able to do in that team is we were able to experiment very rapidly. We looked at like 256 experiments in that 9 months that we were those experiments yielded 3 new lab tests, and the lab tests helped us find 12 factors that drove the durability of our products. We were able to use those 12 factors to help us build trade-off curves that engineers could then use to design new products that were more durable than competition. In the end, what we saw is we worked with the worst durability in West Texas being the best. We were able to show that in our lab data, and then we were able to see that also in the field. We have 10 new products that we've launched to our customers. Those have been accepted. We've developed over $1.2 million in revenue so far this year. We're projected to be about $10 to $15 million by the end of the calendar year.
Hey, thank you guys for watching our video. My name is Jason Holm. This is Sean, Scott, and Brent. We are 3 members. We represent 3 members that represent the West Texas Gang. That's our team name. In case you guys aren't familiar with US Synthetic, what we do is we manufacture synthetic diamond. What you have in your hand is one of our cutters. The black portion on top is actually synthetic diamond that is used to cut through rock for oil and natural gas. So these will drill down thousands of feet, and that's how they drill wells. In January 2016, we estimated our market share in the West Texas area, which is a drilling area, was at 50%. Our standard is to be the preferred cutter in each of our areas, so this is a problem statement. This is well below where we're supposed to be. Our goal statement was, in 1 year's time, by January 2017, to get to 60% market share, so to gain 10% of our market share back. Our problem was a durability problem with our cutters. Our cutters were breaking. These three circles here are three cutters that are being run in this area. The top two are actually our competitor cutters. This is where we sat. We were losing in durability, in strength in these cutters. So we set a goal to gain back this market share by introducing a new product. However, before we were able to work on this durability problem, we discovered we also had another problem. That was that it took us roughly 1,400 days to get a product accepted with our customer. That's 3 to 4 years. In 2016, with the oil downturn, that was not going to work. We had to find a new way to work. So we looked at our manufacturing process, and we saw that one way that we increased speed was to actually go from a batch process to a single piece flow. By doing that, we were able to increase speed on the manufacturing floor. In the research area, in the engineering area, we realized that we were at the batch process stage. We were not near as far along in the lean journey as our manufacturing side was. So we decided to try a hypothesis test. We said if we were to turn us engineers from batch engineers into single piece problem engineers, would we go faster? My paradigm 2 years ago, rewind, I was working on probably 5, 6, maybe 7 engineering problems at once. I would do half time here and then shift over here and work on this. That's kind of where we all were. We decided to change that. We said every single one of us on this team is going to be 100% dedicated to this team. We have to move faster. So that was one way we were going to move faster. The other way is that this new team, we had some strict rules that we adhered to. And that was we had to shorten our learning cycles. So if we had an experiment that was going to take 30 days, we said that's unacceptable and we have to shorten this somehow. We called this the high velocity edge problem solving method, or high velocity PDCA team. A principle of this is identifying what you want to learn and then trying to come up with the simplest way to gain that knowledge. So for example, if you want to find if a piece is going to hold together, but normally you would weld it, you say, well, can I bolt it? Bolting it is faster than welding it. If I can bolt it, perhaps I can tape it. Better yet, if I can tape it to get this knowledge, what if I just hold it? If I'm testing if a shelf bracket is going to work, I can hold it here, and you can find out, oh yes, that's the right size shelf I need or not. So that's one of the principles that we tried to implement on this team. By doing so, this allowed the speed of this team. In 9 months, we were able to run 256 problem-solving iterations, PDCA cycles, on this team. We identified 12 factors that directly relate to the durability of our cutters. We were able to develop 3 new lab tests and create a new trade-off curve directly affecting the durability of our cutters. By doing this, we were able to introduce a product that actually ranked here. So before, where we were clearly the least desirable as far as durability goes, we're now the leader in durability in this application. By implementing this cutter, by introducing this cutter, our market share as of Q1 of 2017 was 61%. We expect this to rise up to 80%. Here is a field test. So this is a blade, and it's called a paired test. So they take the competitor cutter that is the incumbent, that is the winning cutter currently, and they put our cutters in between it and see how it does. We are the only 2 cutters that survived that drill run. The competitor cutters completely were destroyed. That result, along with some other ones, subsequent testing, this customer decided to switch over to us in that product line. We are now the incumbent cutter in that product line. In Q1, that represented $1.2 million of revenue, and over the year, it's going to represent between $10 and $13 million of revenue. So that's sort of the PDCA. What questions do you have for us?
So single piece flow in engineering. So can you take us through that again?
Yeah, so the resources are 100% dedicated to solving this problem, and also you're trying to speed up your learning cycle, oftentimes through creativity. So for example, I had designed an experiment on this team that was going to take 30 days to get back. A team member said, what if we tried a different ceramic, a different material that we could test and find out if this experiment, this 30-day experiment, is going to be successful. We ran it and saw, yes, this produced what we wanted. So then we took the time to actually run the real experiment. But by verifying that it was going to work before we ran it, it really helped us to speed up there. The other thing that allows us to do by forming these high velocity edge teams, it allows us to really drive to root cause, which is one principle we really tried to follow. We had a disciplined set of rules that said when you see a result, you still have to understand why it happens. Past Jason would have said, hey, that's a cool result, let's just give it out there. It's a good solution. Who cares why it works? Just go. They need it, just put it in there. But we really were disciplined and said, we have to go down and understand the root cause. By understanding the root cause, that's what allowed us to move along this trade-off curve. So we're now able to introduce products in any of these different regions along this trade-off curve. So this is one success story of a product we introduced to the field that really worked. Guess what? We have other products that didn't work. Different customers, we gave it to them, they go, no good. We said, that's wonderful. You're here, let's try this one. And they go, great. And within a few months, we're able to get new field tests. So that's sort of what the high.
So how come engineers are so well linked in with lean principles?
Because we saw success on the manufacturing floor. It makes sense that some of these tools are going to be cross-functional. Not all of them, but this one was one that we tried, and we really think it's working out well for us. So.
Thank you, guys.
Thank you so much.
Very good.